Hello and welcome to Lesson 16 Digital Circuits. This video is in addition to Lesson 16. We're trying to show you how to understand number systems. Number systems are crucial to learning digital circuits, so please view this video in its entirety. In the video you will learn about binary to octal and octal to hexadecimal number conversions. So let's begin. These are the objectives for this lesson. Module 1, Introduction to Number Systems and Counting, Decimal and Binary Conversions. Module 2, Binary and Octal Conversions. And Module 3, Binary and Hexadecimal Conversions. Number Systems and Counting. This is Module 1. In this module, you'll learn how to count in decimal and binary and count in octal and hexadecimal. Remember when you was in grade school and they taught you how to count? Well, the decimal number system has 10 digits. So it starts off at 0 and goes to 9, and then it starts over 1 0, 1 1, so on and so forth. The binary, octal, and hexadecimal systems have something similar. The binary system has only 2 digits. That's a 0 and a 1, and they're denoted as bits. Once you get to 1, then you go start over with 1 0, so on and so forth. In the octal system, you have 8 digits. That's 0 to 7. Then it starts over with 1 0, 1 1, and keep going. In the hexadecimal system, you have 16 digits, and that includes letters also. So it starts at 0, it goes to F, and then it starts back over with a 1 0 once you go past F. Remember this chart, because this chart will help you to do your problems. Now, if we look at these decimal numbers, or we look at numbers, when you have the 2 bits like this, then you have a least significant number and a most significant number. So even in this right here, you're still going to have a least significant bit and a most significant bit. In this one right here, you have a least significant bit, which is a 0, and a most significant bit. And it'll be the same for here once you get to 1 0. This is your methods for converting binary to decimal. So each one of these bits right here has got a weight associated with it. So that weight, since it's 4, it's got 4 weights. So those weights are 2 to the third, 2 to the second, 2 to the first, 2 to the 0. So what you're going to do is take this number that's in that position, multiply it times the weight, then add them together, then you'll get the decimal number. So we did the first couple of them. So let's do this one right here. So how many positions do we have? 1, 2, 3, 4, 5, 6. So we're going to have 6 weights. So that's 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. Now you may hear me say 32, 16, 8, 4, 2, 1. That's just a quick way of saying 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0. So let's do this one. So you're going to put that 1 right there. Put your 1 right there. 1 times 2 to the 5th plus 0 times 2 to the 4th plus 0 times 2 to the 3rd, 0 times 2 second, 0 times 2 first, plus 0 times 2 to the 0. So since this is in the 32 column, it would be 1 times 32, so that'd be 32. So that's how we got 32. Now if we did this one, how many bits? How many digits? Or you can look at it bits, where if it's binary, it's going to be bits. But if it's another number system, it'll be the digits. So how many bits do you have here? 1, 2, 3, 4, 5, 6. So your weight's going to be, you're going to have 6 weights. So you're going to have 32, 16, 8, 4, 2, 1 for your weights. Take these numbers that's in each position and multiply them. And then add them up. So that's 1, 1, 0, 0, 0, and 1. Once you multiply them and add them up, you should get 49 for your decimal number. Now, how many bits do we have in this one? 1, 2, 3, 4, 5, 6, 7. So our weight's going to be what? 64, 32, 16, 8, 4, 2, 1. So then we're going to take each one of these numbers, put them in here, and multiply them. And we got a 1 there, we got a 1 there, we got a 1 there. Let's see, we got a 1 there, 1 here, 1 here, and a 0 here. So when you multiply them and add them up, you get 126. And this last one, how many weights? We got the same amount, 1, 2, 3, 4, 5, 6, 7. So your weight's gonna be 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. And then we just put those numbers in there. 1, 1, 0, 1. And let's see, 0, 1, and 0. And then that should be equivalent to decimal 102. Now when you converting the number in decimal to binary, you look at your weights. Since we got the biggest number is 175, we went ahead and put the weight in there that's smaller than 175, but not to go over it. So the closest one to 175 is 128. So these would be the weights for these two numbers. Now the weights for like 29 and the other numbers, what you have to do is you find a number that's closest to 29 without going over it. So what's closest? 16 without going over. So what do we need to make a 29? We need a 1 right here, that's 16. We need a 1 right here, that's 24. We need a 1 right here, that's 28. Do we need a 2? Nope, that'll make it too much. So we need a 1 right there. So all you're doing is 1 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. Now 15 and 14, you can get those off the chart. That's why it's imperative that you learn your chart. Okay, so for 175, you want the biggest number that's closest to it without going over it. So and that's 128 for its weight. So we put in a 1 right there. So that's 128. Now 64, that'll make it too big. 32 would make what? 160. Okay, so if it's 160 with 16 to make it go over. Okay, so what else would we need? We need an 8, so that'll make it 168. And what else we need? We need that 4, 172. We need 2, 174, and then we need one more, 175. Now when you have 164, what you got? This one's gonna be kind of similar. We got a 0 there, 0 there. What does make? 160. Okay, so we don't need that 16, we don't need that 8, we need that 4. And we don't need that 2, and we don't need that 1. So all it is 1 times 128 plus 0 times 64 plus 1 times 32 plus 0 times 16 plus 0 times 8 plus 1 times 4 plus 0 times 2 plus 0 times 1. Now when you're doing 70, what's the closest number to 70 without going over? For a weight, that's 64. Put your 1 in there. And what that leaves, that's going to leave 64 minus 70 to take away 64, that's going to leave 6. So we don't need that one. We don't need that one. We don't need that one. We need this one. And we need a 2. And we don't need that one. So that's 70. 50, what's the biggest number that'll go into 50 without going over? That's 32. So that's where our first weight would be. Then once we get 32 and 16 is what? 48. So that'll leave us with 2 more left. So we got to put a 1 in the column where there's 2 at. And that's how you do it. 85, what's the closest thing to 85 without going over? 64, so we put a 1 right there. 64, take away 85. So we don't need the 32, that's gonna make it too much. So 64 and 16 makes 80. Do we need 8? Nope, that'll make it too big. Do we need 4? Yes. So we have 64, 16, that's 80, 84. So we need a 1, so we don't need that 2, so we need a 1. So when you take this, 1 times 64 plus 0 times 32 plus 1 times 16 plus 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. That should give you 85. So now there is another way of doing this also. So let's look at the other way. This method right here is called repeated division by 2. And what this one does right here is that you have to take the decimal number and divide by 2 and keep dividing by 2 until you get to 0. Then everything that's a remainder, no matter what value it is, you make it a 1 if there is a remainder. You make it a 0 if there is no remainder. Okay, so you're going to go through it like this right here. And then when you get through, you're going to take the most significant bit, which would be the bit all the way to the left. And then you're going to write this number, 1100101. And that'll be your number conversion. So what you have to do with these, you just need to practice. And just remember, you're doing the repeated division by 2 until you get all the way down to 0. Till you can't divide anymore. So this is module 2, binary and octal conversions. In this module, you will learn how to convert from binary to octal and octal to binary. So we took this chart from up above, so that's why I told you need to learn that chart. So it takes 3 bits to make one octal number because it starts over with 7. So you're going to break your binary bits up into groups of 3. So let's do it. Let's break them up. Some of them I've already done already. And then all you want to do is just find these 3 bits and find the octal number that they correspond to. So 000, that's 0. 100, what's that? That's 4. Then you got 1, 4. Then right here, what's 010? That's 2. What's 111? That's 7. What's 010? That's 3. 101 is 5. Then you got 100 for this one. 101, that's 5. 001, that's 1. 110, that is 6. 010, that's 2. 111 is 7. 111 is 7. And then this one right here. And incidentally, if you don't have enough to make your groups, you start from the right and you go all the way over. Okay, so let's do this right here. To make your groups. So 111, so 1, 2, 3, that's 3. 1, 2, 3, that's 3. 1, 2, 3, that's 3. Now if I didn't have this 0 right here, then I can put a 0 there to make that a full group. So all I'm going to do is take each one of these groups, find the octal number to go along with it. So 011, that's 3. 110, that's 6. 011, that's 3. 000, that's 0. Now, when you convert from octal to binary, all you're going to do is take the binary bits that correspond to that octal number. So you're just doing this in reverse. So if you got a 1, what's a 1? 001. And then you got 0, 000. Then you got 0, 000. Now if you got a 5, 7, what you got? 101. What's a 7? 111. 63, 110. And what's a 3? 011. 157, 0001. What's a 5? Let's see, I put an extra 0 there. What's a 5? A 5 is 101. And what's a 7? 111. Okay, so what's a 1? A 1 is 001. And what's a 0? 000. Now, the 6 and 7, see if you remember your chart, then you will know that this is 110 and 7 is 111. 15 would be 1000. Let's see, would that be right? Let's see. Let's make sure we got this one right. Okay, so that would be 1 and then you have 5. So that would be 101. Let's see, 1001. And the 5 is So that's right there. Okay, so 175, you got a 1, then you got 111, then you got 101. Okay, so that's how you do that. Now let's continue. This is module 3, binary and hexadecimal conversions. In this module, you'll learn how to convert from binary to hexadecimal and hexadecimal to binary. So this is what we did here. Let's see. Let's take these off. Now the rest of them is going to be left for an exercise for you to do. So we're just going to do a couple of them. So how many binary bits does it take to make a hexadecimal number? This makes 4. So what you have is you're going to split these up into groups of 4. So let's split them up into groups of 4. Okay, so let's split them up. Start from the right, count over. Start from the right, count over. Split them up into groups of 4. So once you split them up into groups of 4, just take whatever binary number that it is, write the hexadecimal equivalent for it. So 1100, that's a C. 1111, that's an F. 0110, what is that? 0110, that's a 6. 1000, what is that? That's an 8. 1111, what is that? A F. That's a 1. What's 1010? That's an A. What's 1101? 1101, that's a D. 0101, that's 5. Okay, so the other ones, you can just get these off the chart. That's why it's imperative to remember your chart. Now this one right here, when you're going from hexadecimal to binary, all you do is just take each digit and write its binary equivalent. So when you have 20, find 2. What's 2? 0010. What's 0? 0000. Now again, you don't have to write these leading zeros. We're just doing it for clarity. 50. 0101. What's 0? Okay, and then we just take that off. 75. That's 111. What's a 5? 0101. What's a 7? What's an A? What's a 6? 6 is 0110. What's B? B is 1011. And again, you don't have to put that 0 right there. So we left the rest of them as an exercise for you to do. But that's all you're doing is you find that whatever the hexadecimal digit is, then you write the 4-bit binary equivalent to go along with it. And that's how you convert from hexadecimal to binary. This is just a picture of one of your lessons that you're going to be doing, some practice work. And you're going to be learning how to count from 100 to 110 in decimal, in binary, in octal, and hexadecimal. So these are just your weights up here. And just remember what system you're in and how that made the weights. All you're doing is taking the weight, take the number that's in that position times that weight that's in that position. And then add them up. And that's how you find these numbers. Now, hopefully this video has helped you to learn about number systems, because it is crucial that you understand number systems. So hopefully this helps. Have a good day.